Hello everybody. In this video we're going to take a look at how to make an equilateral triangle inscribed in a circle. Okay, so to start with this we're going to create two congruent circles. Now I'm going to close my compass a little just so it's a little smaller. I don't want super big circles. So I'm going to create my center point. I'm going to put, my compass in a spot, and I might even put the point there so I know that's the center. I'm making sure my compass is nice and tight, and I'm going to make a circle. Okay, and I'm just going to make it a little smaller here. I'm going to use that strategy of just kind of going around with the paper. This is why it's nice to have like a desk space. It's always good in geometry to have like a nice flat surface, plenty of, free of any like obstructions so you can create and draw. I love geometry. It's super fun. Okay, so there's my circle, circle A, okay? Now, I'm going to create another circle that is the exact same size. I am not going to change anything on my compass. I'm going to keep everything the same. And I'm going to use, when I construct this one, I'm going to use the edge of the circumference of my circle. I know that from here to here is a radius, right? I know that from the center to the edge of my circle is a radius. So I'm actually going to use that to create another circle that's going to have the same radius, same circle, same size, congruent, everything. And I'm going to create another circle, and I'm going to go around very carefully. Again, it's fun to use the digital tools, but I like using paper and pencil too, just so you guys can have a chance to do this by hand. It's always fun to draw by hand. We use the digital tools and I'm all for it, but this is kind of fun. It's like art. Okay, so I've constructed two congruent circles. Here's the center of circle B. Here's the center of circle A. Now, just like we did in our perpendicular bisector, we know that the radius of circle A is congruent to the radius of circle B, and that's how we constructed our perpendicular bisector. Okay, so we're doing sort of the same thing here, but now we're going to use the point of intersection where they intersect right here to help us construct a triangle. So I'm going to label my points. Remember, I told you always make sure I label my points. A, B, C. Okay, or you could do it. I said circle A, circle B. This could be point C. And then I'm going to use my straight edge to come over here and connect these line segments. So here's my first line segment together here. Okay, try to be as precise as possible. Okay, and then from A to C, and from C to B. Now, what do we know about equilateral triangles? We know that equilateral triangles have to be equal lengths. So A to C, C to B, and A to B all have to be the same length. So I'm going to do a quick check on that. I'm going to use my centimeter side, and I'm just going to see if they're the same. So look, C to B, line segment CB, is 3.5. Okay, let's see if I did this correct. Line segment AB is 3.5. And line segment AC, 3.5. Okay, so far, I know I have a triangle that has three equal sides, measured equal sides. Let's check the angles. Now, I know that a triangle is 180 degrees. So if I divide that by 3, then I know that each one of these angles has to be 60 in order for it to be an equilateral triangle. So let's do a quick check. Again, now, just like usual when we're trying to do anything with constructions, you can see my line doesn't go all the way up. So sometimes in geometry, you might need to extend the line. Form a nice, I just like to make a nice light. I don't want it to be super, see how I'm just kind of doing this? I'm making like a little extension to the line without it being too dark. Okay. So now I can measure angle CAB or BAC, doesn't matter which order you go. Make sure the center is right in the center. And look at that, pretty close, 60 degrees. Okay, so we're going to say angle BAC is 60 degrees. Now, I'm going to rotate my paper around and I'm going to check the C angle. Put my center right in the dot and just make sure. Now, it looks like this one might be off just a smidgen. I'm just going to check. And I can see when I look at it really closely that I didn't quite use my straight edge. See this? I'm just going to adjust it just a little bit because it looks like I might have been off a little. Do you see? It's very small, but the further away you get from the center, the many more degrees it would be off. This is why it's so important when back in the old days when ships used to use compasses to navigate, they had to be very precise because if you're off 1 degree, the further in time you go, that line is going to get further apart. So, all right, now let's see. I made my fix, and let's see if this is 60 degrees. Yeah, not bad. I'm off just a little bit, but it's pretty close. Okay. So angle BCA is 60. And let's try the last one real quick. Rotate this around and get this last angle. Oh, make it a little stretched out here so I can see it. And that one's really precise. That was a good one. So angle CBA. Okay. So now I just proved that I made an equilateral triangle. Now, what do I know about circles? That I can prove this without doing any measuring. I know that these two circles are congruent. Okay, so because circle A and circle B are congruent and I'm using the same center point, that means A and B, circle A and B have the same radius. And because they have the same radius, that means this A to C is a radius, B to C is a radius, A to B is a radius. They're all congruent. They're all equal, which is why I was able to make a equilateral triangle. Hope you have fun with this.